We need to solve the initial value problem x prime equal to a times x, where the initial condition x at 0 is 1, 0. A is this matrix. You compute the eigenvalues and eigenvectors for A. You get the repeated defective eigenvalues case, where we have only one eigenvalues lambda equal to 2. So this algebraic multiplicity 2, but the geometric multiplicity is 1. We have only one linearly independent eigenvectors, v, 1, 1. Or you have any multiple of these vectors, so a, s, as long as a is non-zero. Then this is the ordinary eigenvectors. Then in this case, you need to find a generalized eigenvectors. So when choose one linearly independent from V, I choose 1, 0. And we need to update the chains. So V1, the ordinary eigenvectors will be A minus lambda I times V2. So A minus lambda I times V2 will give us the first column because we choose V2 to be 1, 0. So this one gives us the first column of matrix A minus lambda I. We get 1, 1 is an eigenvector. So in this case, interestingly, it gives us the exact vectors here, but in general, it can be different. So we have one ordinary eigenvectors and one generalized one. And with that, we build the general solution. xt c1 v1 is lambda t, c2 v1 t plus v2 is lambda t. So this case is lambda t is in common. You can pull it out. You have c1 v1 plus c2 v1 t plus v2. And you have this general solution. Now they give us the initial condition, so you use the initial condition to solve for C1, C2. So you plug in t equal to 0, you get C1 plus C2. So that's the first row. Second row, C1, E 2 times t, E 2 times 0, for t equals 0, you have 1. So this term will not disappear, equal to 1, 0. You have a system of two equations, variables C1, C2, you solve for that, C1 equals to 0, and because C1 is 0, C2 is 1. Replace that into the general solution, you have the solution for this particular example. So xt equal to this. So this is a solution of the initial value problem we have at the beginning.